Discuss 3.5 quadratic inequalities. If I want to ask a simple question before I start. So now this is x equal 3 line. I take through 2 points here. So this point is 3. Let's say 2. This point 3, 7. Now you know that this 7 value is greater than 7 value is greater than 2, or 7 value is higher than 2. So instead of this 2 and 7, can I give a symbol? This is I'll put YA, and this is YB. Now, which one is right? YB greater than YA, YB equal to YA, or YB less than YA? It is obvious that we know that this is the right one. YB is bigger. It has a length of, this is the length. This is the YA length. This is a rough idea. You can see a rough figure on this. So ultimately, what I want to show that YB is greater than YA. Another point we'll consider. X equal 6. 6 C. This is 6D. 6YD. Now, what you can tell about, now we know YB greater than YA, same as YD value greater than YC. This is a line, and this is a curve. I make it to a curve. So then, to understand the Y value of curve, I put Y bar B. Y bar. This is also Y double bar. Now in terms of curve we'll write. This is Y bar. YB bar greater than YA double bar. YD bar greater than YC double bar. Now I put this boundary is P, and this boundary is Q. Simple Q. In general, if I look at another point, it's still the same in this one. If I take another point here, let's say this is 1.5, still you can see that Y M double bar, this is X value, Y N double bar. bar, not double. So we know that yn bar greater than ym double bar. So what is our conclusion? Basically, we can write y bar greater than y double bar. Is it always right? Is this true for all the area? We don't know that. But we know that it is true for from here to here, P to Q. So y greater than y bar is true for the interval P greater than x greater than Q. In this interval, this is P from P to Q interval, which is true. Another example we'll discuss. This is one curve. This is another curve. I'll consider this is y bar curve. This is, okay, I'll put this is y double bar, this is y bar. What you can tell about the y value of this y bar and y double bar curve? If you look at for same x value, let's say x equal 4. What is this point? X 4 and y bar I put 1. Okay, I'll put y bar 4, 11, and this is 4 as well x value, y double bar 4. Now I know that y4 double bar 4 greater than y bar 4. Another point, if I consider the same x value, this is x equal 8 or x equal, let's say 7, 7 y bar 7. This is 7 y double bar 7, and we know that y7 double bar value is greater than y7 bar value. In general, do you mind if I write y double bar greater than y bar? Y double bar, all the values, the curve y double bar, y value of all y double bar curve is greater than that of values. So in general, I can write y double bar is greater than y bar. The value of y double bar greater than y bar. In between which interval? Okay. In between B to C. B greater than x greater than C. In between B and C, the y bar curve is above the y double bar curve is above the y bar curve, because all the y value of y double bar above. all the y value of y bar is below y double bar. It is only possible B to C. We don't know what is happening after this. What do you think that like this, if the curve go like this? Now this is y double bar. Now this is y bar. I'll put this x value is A. Curve is going from here. Now what will happen? From A to B it is opposite. All the y bar values, okay, in other way, y double bar less than y bar. Who is bigger? Y bar is bigger. Y bar value is bigger from where to where? From A greater than x greater than b. Okay, I'll put this side as well. I'll bring the curve up to here. Now this is y bar again. This is y double bar, the curve. I have to use okay. This is that curve. Now, when you consider from C to D, what will happen? Again, y double bar is less than y bar from C greater than x greater than. From this interval, y bar becomes worse, or y bar got the higher y values. In this interval is the same, but in this interval it is opposite. Y double bar get bigger values than y bar. Having this knowledge, we'll discuss an example now. Let's discuss this one. Find a set of values of x for which 12 plus 4x greater than x squared. Now, this x squared mean y equal x squared. It is a curve. 12 plus 4x. Y equal 12 plus 4x. This is a line. So, since they have both y, I'm going to name this one. This one is y curve, yc. Yc mean y curve. And this is yl. This is relevant to line. So I just name, otherwise it will difficult to identify both y. So now yc and yl. So when I write here yl greater than yc. Now you need to find an area where all the y value of yl greater than all the yl of yc. If I draw a graph, this is y equal x square graph. Y equal x square. Now we name this one as yc, y curve. And this line, I name this as y curve. This one. Uh, it is a line. This is YL. And this is an intersection point, I can say. I'll write A and B. So this is the x value A and this is B. Now my question is, YL greater than YC. Always the Y value of a line is greater than Y value of curve. Which area? So when I bring the ruler here, so this is going to be this. We have same x value. Let's say x value is minus 10 and this is y value is 5, and on the line x value is minus 10, y value is 1 in this point. So I can see that now I can see that 5 is greater than 1. 5 is greater than 1. So I'll come to a conclusion that okay, in this area, likewise, if I do the another point, still the same. So then from here to here, I can see y curve is greater than, in other way, YL is less than y curve. Y line value, y value of the line is always less than y value of curve up to A. So this is minus infinity, this is plus infinity. I will write it from minus infinity to x less than A in during this interval YL less than YC. How about A to B? A greater than X greater than B. What you can tell about YL and YC? Which one is higher? If you take one value here, 1 point, or same X value, let's say 1, this is 9, this is 1.4. We know that 0.4 is less than 9. So the line, the coordinate y value of line is greater than the y value of curve. If I take another point, it's still the same. So from A to B, I can clearly tell that the y value of line is higher than y value of curve. Now from B to C, what is happening? B greater than x greater than positive infinity. I can clearly see that again y curve is y value of y curve is higher than line. Now the answer is here for the question. find the set of values for x for which uh, this will greater than x square, which is yl greater than yc. So answer is this one. So it will match with this inequality. So this is the answer for the question. But we need to find set of x. We find set of x. A greater than x greater than b. This is the answer. But we should know what is a and b. Then answer is complete. Now we'll solve the equation. I'll try to solve here. 12 plus 4x greater than x square. So x square minus 4x minus 12 less than 0. This will become, okay, I'll put equal sign. So I'm solving those two equations. Simultaneously get the intersection point. So x minus 6, x minus plus 2 equals 0. X equals 6, so x equal minus 2. Now I know that this answer is what? Minus 2. A is minus 2 and B is 6. My answer is complete now. Which area that x square value always greater than 12 plus 4x? Sorry, 12 plus 4x greater than x square, which is yl greater than yc, in between A and B, which is minus 2 greater than x greater than 6, yl greater than yc, or 12 plus yl mean 12 plus 4x greater than, I can't see that, or 12 plus 4x greater than x square. Now you can look at the page 49, example 10. So in page 49, example 10, part A, find the set of values of x for which 12 plus 4x greater than x square. I work out that sum. This is the part A of example 10. But they work differently. In this book, it has a different curve. Now what is going on here? It has a different curve here. Now what is going on here? Now I'm going to explain that bit. I'll rewrite here 12 plus 4x greater than x square. So then x square minus 4x minus 12 less than 0, same thing. I'll consider this curve y equal x square. Y equal x square minus 4x minus 12. And I'm going to draw this curve. So how do you draw a quadratic curve? This is a value is 1. It means it has greater than 0. It has a minimum. Right? We did this one. And we know that root is 2 and 3. We work out now. X equal minus 2 and x equals 6 are roots, and what is the symmetric line? Symmetric line we can get by completing a square. X square minus 4x minus 12, then x minus 2 square minus 4 minus 12, x minus 2 square minus 16. I'm going to draw mm, this curve in the same graph. This is y equal x square. Now x minus 2 equals 0, x equal 2 is the symmetric line. If this is 6, this is minus 2, this is 0, 0 to 6. This is 3, and somewhere here 2. This is the symmetric line. And minus 16, minimum value at minus 16, and it's going through 6 and 2. This is the graph. Now you can see that instead of this setup, instead of those two curves, now we are switching to a one curve. Now instead of those two curve, now we are considering this curve, and we will get the same answer by looking at this curve. In this book, you can see this part. I will switch this equation inequality around. X square less than 12 plus 4x. This is still the same. Right? I rewrite this one. This is still the same if I write x square less than 12 plus 4x. Now you have two choices. You can find the answer for this solution doing this one, drawing those two curves with this black and blue setup. Or you can switch into this red curve. You can find the answer in terms of this curve. So you can do both, but this is much easier. And now you know what is going on basically. Now, in this setup, the x square value is less than y value is less than the line, y value of line. It is same as in this curve, y value is less than 0. So if you look at this red curve, and can you tell me that which area where y value less than 0, you can see that this area of the curve, the all the y values of this area of the curve is less than 0. So it is exactly matched with this one. All the y value of x square is less than the line. So we switch off this system and we jump to this new system now. Now we are working on their new system. Also you can see that the intersection x value of this intersection point is the root to this the red curve. is the root to this equation. The intersection point of those x value of intersection of those two curves is same as the root of root to this curve. Now, I am with this curve y equal x square minus 4x minus 12, and now y less than 0 area. That's the area you want now. What is the area y less than 0? Now you know that all the y value is here. Y, if you take any point in between minus 2 to 6, all y values are less than 0. I mean, y equals 0 line, this one. X-axis mean what? X-axis. X-axis mean y equals 0 line. So all other the beneath points has negative y values. So the answer is minus 2 greater than x greater than 6. This answer is matched with the previous answer for this one. Now I close this graph. Now you can't see the graph. Now how can you find the answer for this question? Now, this is the question. You want to find the area x square less than 12 plus 4x. It means x square minus 4x minus less than 12. It means y less than 12. Now we know the answer this one, but now you are here now. We need to find the answer for this one. It means we'll bring this one. We want to find all the area, the y value of this curve, negative y, area where y value are negatives, because this is the symbol. Okay, I'll erase this part as well. Now you have only here. Now how do you check? Now you can do one thing, is trial and error. You can get the number line. So you have a number line now. We don't know so we have to trial and error. If I put minus 10, the answer is going to be minus 10 square. I take minus 10. Minus 10 square minus 4 times minus 10 and minus 12. So this is 100. This is plus 40 minus 12. Okay, this is going to be 140 minus 12, 128. So 128 less than 0? No. So 128 point, the y value at 128 point is not the right answer because it is not matched with the inequality. Another point. Likewise, we have to check the whole number line like that. Instead of that, what we can do, we can find the roots of this one. So we know that the picture because it will exactly match with the roots. The intersection point of those two curves is match with the roots of this equation. Then we need to find the root. We know that root is x equal minus 2 and x equals 6. Now we have a good clue. Okay, 2 to 6. Instead of blindly looking at all the uh, values, now we have a three separate clear area. Instead of that, now we are checking this area. What are the three areas? Minus 2, minus infinity greater than x greater than 2. Then 2 greater than x greater than 6. Now number line I divide into three parts. Less than 2 in middle and then more greater than 2. Now instead of checking all the values, I can with checking three values I can come to the conclusion. So I will take one value. Actually, this is minus 2. Less than here. We already picked up minus 10. When I pick up minus 10, what is the answer? 128. Greater than 0. But we need less than 0. So that doesn't work. 128 greater than 0. But we need 128 less a value. This one less than 0. So it doesn't work that area. Now let's take any value from 2 to 6. I will take x equal, here x equal, I check minus 10, 120. The best way is not equal to, not less than 0. I will take x equal 0 here. It is in value in between. Then this is become 0 and answer is minus 12. That works. Minus 12 is less than 0. That is right. This is wrong, this area. Now, what we can see here? X value is more than 6. When I put 10, what is the answer is going to be? 10 square minus 40 minus 12. 100 minus 40 minus 12. 100 minus 52, 48 answer. Is 48 less than 0? No. Then this is also, this area is not fixed to the inequality. Now you can see that. So only the acceptable area is 2 less than x less than 6. Now you can see we work this sum. This is what is really happening. But we instead of that we switch into this curve and we look at from the y value. We know that by looking at the graph, those y values are less, and we can simply by graphically I can answer this question by looking at this minus 2 greater than x greater than 6 for the answer. But if they don't have a graphical picture, then what we can do? So we have to simplify like this, and instead of checking random values throughout the number line, we can find the roots and we can break number line through these roots because we know that the intersection point of those x value of intersection point of those two curves exactly match with the roots of this curve, and it works. That's why. So now Now you don't need a curve or any graphical method. You can mechanically find, right? Just a calculation. You get the roots and you divide the number line into the whatever to according to the number of roots, and then you check the value versus this one. We are talking about y values. We want to look at y values, but that y values we look in terms of x. So this is the scenario behind it. So hope you can understand, or you can try to understand. Uh, if you look at exercise 3A, you can see that the question number 1 is especially given to practice these areas only. They don't talk about the graph, but two curves, but they only consider one curve, and they want to know that this setup. They are practicing this setup here. The one we discuss the same sum before I finish this part. Even I can look at this way as well. This is y curve equal x square minus 4x minus 12 and y line equals 0. So this is y equals 0 line. So y equals 0 less than y curve less than y line. So you can think about that way as well. But I didn't introduce that part in the discussion because you may get confused. Even if you can't understand this one, just leave it.